Hi, I'm going to walk you through Haskelly for Visual Studio Code and the scaffolding exercise automation tool. Haskelly is a Haskell plugin for Visual Studio Code, which is made by UCL Computer Science students with Microsoft as an industrial partner. The team is Janos, who is the team leader and is responsible for clientization, Marco, who is the deputy team leader and also holds the technical lead, and Marti, who is the chief researcher and chief editor. Our supervisors are Dr. Dean Mohamed Ali and Dr. David Clark from the UCL Computer Science Department. Haskelly's features are syntax highlighting, code completion, a scripted toolchain with Haskell's components, so you can run it as a program or using GHCI, and also quick check support. Let's take a look on the architecture of Haskelly. We have different approaches. One is we're running stack run Haskell and stack run directly in the integrated terminal via Studio Code. Another one is, in order to run GHCI, we run a JavaScript file that pipes a process output to its own standard out and handles the input. In order to run quick check, we are using a spawn process and parse the output to the display as a feedback. Code completion is directly integrated using a dynamic spawn process. Let us take a look at the demo.
So we are inside VS Code and we've opened a Haskell file, and since we have Haskelly installed, it has been automatically detected that we are writing Haskell. The first thing that Haskelly does is provide code highlight, as you can see here. Also, it provides code completion suggestions. This takes into account the Haskell standard library and imported package, as well as already defined functions inside the file. Haskelly also offers three ways of running Haskell. The first one is through the GHCI, which is the interactive compiler. This allows us to call any method defined inside the file to test our code. Also, we have a way of just running the file, which takes the main method, as you can see here. And finally, there's QuickCheck, which is a library that provides randomized inputs for functions in order to test our code. So if we click here, all the prop functions inside the file will be run using QuickCheck. And Haskelly will tell us if all the tests pass or if some are failing. If instead of finding a single Haskell file, Haskelly finds a stack project, it will adjust the two buttons here underneath for stack run and stack test. Stack run will build and execute the stack project. Finally, stack test will run all the tests defined in the stack test folder. So this will let us know if all the tests passed, as we saw earlier.
As you can see, we have already a working version, and we published an alpha version to Visual Studio Code. As you can see, we have already over 500 downloads. Let's talk about the scaffolding exercise automation tool, also called SEED. SEED is cloud-based, which allows us classroom analysis. It also allows students to load encrypted files into Visual Studio Code and lets them check if their answers are correctly. SEED is built with Azure using the serverless programming pattern. The whole code base is hosted in a repository, which allows an automatic deployment. The Azure web app manages authentication, which allows professors to log in with their UCL IDs. And Azure functions are run on demand. Let us take a look at the demo.
So professors can create their lab assignments inside VS Code following a syntax very similar to Markdown. First, they need to write on the top of the file two identifiers, the user ID and the assignment ID. Then they can start writing questions and nested exercises. For each of them, they give a title and the code that fulfills that exercise. Once professors have finished writing their seed files, they can log into the dashboard using their academic emails thanks to Microsoft Single Sign-On. Once inside the dashboard, professors can create new assignments, giving their name, selecting a classroom, and providing the seed file that they've created in VS Code. Then, the dashboard will generate the encrypted file that they can distribute to their students through Moodle or any other educational platform. So now I'm in the point of view of students who have been given an assignment through Moodle with a PLL file. When they open it in VS Code, since they have seed installed, a Haskell file will be automatically generated with what they have to program. Also, because they have Haskelly installed, they get all the code highlight, code completion, and buttons here underneath for running and testing Haskell. When they've finished the assignment, or they think that the code is good enough to start testing it, they can click this check answers button, which will run their code and check it against the one that the professor wrote to see if it's correct or not. Then professors can see statistics on the assignment in the Analytics tab. This includes the completion rate or insights on each of the questions.
What are the next steps? We need to do more testing of the alpha version, especially on different operating systems. Also, we need to progress the V model to test data and developing the cloud solution together with the Seed VS Code integration.